Hi guys, so we're going to be discussing problem 6, but before that, we're going to review the decoder. So hopefully you remember your binary, but if not, we have the 0, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, and then 1, 0, 0, 1, 0, 1, 1, 1, 0, and then 1, 1, 1. So for the decoder, we have a selector, but that selector's thing is to just you know, select the certain output that we want to enable. And by enable, we mean logic high. And by logic high, we mean that the bit is 1. So let's have a Logisim demonstration again. So let me put all of this to 0. So right now, 0 is being enabled because our selector is 0. But let's say I want to enable 6. So I'll just have to have 1, 1 here. And then if I want to enable 7, then I can just change that bit to 1. So that's just, the certain concept of a decoder. And let's proceed with the problem. So the 7 segment display was discussed in your EEE 113 class, but this 7 segment display is always on, meaning the lights are always on, and when we enable a certain bit, then it turns off that certain segment. So let's say if I want to have this O here, I can enable G, but that disables the light. So let's see. We want to, of course, spell this out, and we already have multiple letters that are the same, such as the B and then the A. Yeah, those two. So what we're going to focus on making is this B, this O, this A, this C, this F, and E. For this certain problem, we want to have all the inputs connected to something. We don't want any blue lines here. So I'll show you my specific implementation for this problem. But for the concepts, you have to understand that there are different types of implementations that you can do with this, as long as you follow the instructions where all has to be connected, and yeah, you can use it to your advantage. So the first thing that I started with is the 0, which I wanted to assign to the binary 0, 0, 0. And with that, of course, as I mentioned earlier, this is segment G. We want to enable segment G to turn off the light, which sounds like a very confusing analogy, but then just think of it as enabling something. So yeah, we want to turn this off, so we enable it, and that's segment G. And for this, what I did first was I drew all the lines, then I connected this specific line to an OR gate. So this one, we can ignore this for now, but for the specific 0, 0, 0 implementation, we can assign 0, 0, 0 to letter O because G is enabled. So either one. So right, for an OR gate, you choose either one. As long as either is enabled, then this output of G is already enabled. So to a more complicated one, we want to have letter F. Let's go back to this 7 segment guide. So we want A, F, and E, and G to stay on. So now we have to enable B, C, and D to turn off. So let's go back for F. So I assigned this to the binary of 2, though you can assign it to any again, as long as you remember to enable B, C, and D. So what I did was added more OR gates, then just connected it to each one. So you can ignore the rest for now, but this is how I implemented F. And let's see. For A, same concept applies. We want to enable D so that it turns off. And then I assign that to 3 for, any reason, for no apparent reason, but you can see the thought process, how it's coming to life. So yeah, for D, we want it to be enabled. We want D to be the only one that's enabled, which is why it's still connected to an OR gate, but as you can see here, A is actually connected to an AND gate, and that's why A, E, and or F are not enabled here, and only D. And that's the same for all. Specifically for this, if you notice, having all the decoders off would, make it like would make it always on. As you recall, it's an always on segment, but you want everything to still be connected. So what I did was everything that wasn't used, the A, E, and F segments, I just connected them to an AND gate because they would never be enabled, because these two would never be one at the same time. And why? Because they're in different sections. So the only time that A, E, or F would be, well, A, E, and F would be one is if this node here was connected at the same node here. So yeah, that's the con. You can try this on your own with different implementations, because the concept here would, help you understand. Understanding the concept is already like half the work that you can do for this problem. So yeah, next video is computer system.